Okay, class, let's put this together. Let's say, for example, we have a soccer ball that is kicked at a speed of 20 meters per second at an angle of 35 degrees above the horizontal. So I'm going to draw that sketch, and it might look somewhat like this, where we have the 20 meters per second as our initial velocity. I draw these horizontal and vertical components in there to remind myself that I need to break this 20 into that horizontal part and into the vertical part in order to do my math. I'm also going to be thinking about this as a projectile. So after the kick happens, the force of gravity is the only force acting on it. So partway up the path, I'm going to have less VI, but the same VX. The VI will decrease till it gets to the top where it'll be zero. And then it's going to accelerate the same rate downwards. And so it's going to increase its value, its magnitude, until it gets to the same amount of size but opposite direction that at the very instant before it hits the ground. Okay, so those are the things I'm going to be kind of thinking about. Questions like this, we can answer, like how far away will it land? The ground is level, will it ignore air resistance? We're going to solve for dx, okay? The best way I found to do that is to follow these steps. Sketch our triangle, find our vx and vy, make our xy list, solve for one of those to find the time of flight, and then use the other component, either x's or y equations, to solve for what we're looking for. I know this is how far away, it's a distance, so it's going to be a dx that we're looking for in this case. All right, so let's get started. I made my triangle down here. And I even put in the fact that my components in x can be resolved or found by using sine, cosine, and tangent. So I'm going to take 20, which is the hypotenuse, times the cosine of 35 degrees. That gives me 16.4 meters per second for the x initial velocity. For the y initial velocity, I'm going to do 20 times the sine of 35, and that gives me about 11.5 for my initial velocity in y. Once I have these values, I don't need this value anymore because I've replaced the 20 with what its value is in x and what its value is in y. All right, now that's important because when we solve our equations, we're looking for a dx. So I can only use the x velocity. I can't use the 20, and I can't use the y velocity either. These are off limits. I have to use my x velocity. So in order to find that, I'm going to use the x velocity as dx over t. That would be great. I'd be done if I knew the time in the air. Now remember, the time in the air is from when it was kicked to right before it lands. And in order to find that, I need to use my y values and solve for time. I can then plug time into the x, and we can solve for our distance traveled. All right, so in order to find this, I'm going to find my time in the air using y. I'm going to pick an equation, but I also have to think about some concepts here. I mentioned this already, but the amount of velocity that this will have in the beginning, so this might be our 11.5 meters per second positive in the y direction. At the very top, it's zero, but then right before it hits the ground, it will have the exact amount that it had in the beginning, so 11.5 meters per second, but pointing in the opposite direction. Remember, if we say up is positive and that means down is negative, this must be a negative 11.5. So I can put that into my chart, and now I know another value that will help me solve for time. I know the acceleration is negative. I know the final velocity is a negative 11.5. I can choose an equation like the change in velocity over time is acceleration, solve that for g, which is the specific acceleration of gravity. All right, so we're going to have g here instead. And then I can substitute in my final and my initial velocities divided by the acceleration of gravity to find the total time in the air. I'm going to plug my numbers in. I'm choosing a negative 11 as my final velocity, 11.5, and 11.5 is my initial velocity divided by negative 10, which is the acceleration of gravity downward. That makes negative 23 over negative 10, or about 2.3 seconds. That 2.3 seconds can now substitute in to the that we solved in the y, can also substitute in for the x direction. So I'm going to take that over to my x equation, rearrange to solve for distance, taking the velocity times the time, plugging in the velocity in x, which is the 16.4 from my chart, times the 2.3 seconds we just found, gives us a horizontal distance of 37.7. We'll be using this process a lot in these problems. I want you to give it a try in the next example problem, and then we'll talk about the maximum height in our next video. Thanks, have a great day.